everyone. The components of a mixture can be separated. Here I have a mixture of clay and water. How can I separate them? Do you know what I have to do? If not, do not worry. In this session, we will be learning about the separation of mixtures containing solids in a liquid. So, for separating these mixtures, we have mainly 6 methods. So, the methods are filtration, centrifugation, evaporation, crystallization, chromatography, and finally distillation. So, we are going to see all these 6 methods one by one in detail. So, the first method is filtration. The process of removal of insoluble solids that are present in a liquid by using a filter paper is called filtration. So, what is a filter paper? A filter paper is a round piece of special paper that contains millions of pores or holes which can be seen only through a microscope. These holes in the filter paper allows liquids to pass through them, whereas huge or large solid particles like sand, chalk powder, etc., they will not pass through these filter paper. Thus, a solid which remains insoluble in a liquid can be separated by using a filter paper. The leftover particle or the solid substances that remain in the filter paper can be called as the residue, and the liquid particles or the liquid substance that we obtain after the filtration is called as a filtrate. So thus, filtration is the process of separation of insoluble solids from a liquid. So now in our day-to-day life activities, filtration is a common process. For example, when we prepare tea, we'll have to separate tea leaves from tea, right? So for that we use a tea strainer. So it's a common example for filtration that we use in our day-to-day life. Also, the water that is supplied in cities, that undergoes a long process of filtration and purification before it reaches to our hands. Firstly, the water is collected from a nearby water resource like river, lake or a reservoir. Then they are pumped into a sedimentation tank where all the insoluble particles will get settled down at the bottom of the tank. From there it is pumped into a loading tank where alum is added into this water. So these alum, they get loaded or they get fused with the suspended clay particles in water, and they together get settled down at the bottom of the loading tank. Thus we can separate out or we can make the clay particles that is suspended in the water to get settled down in the bottom of the loading tank. Then this water is made to pass through a filtration tank in which 3 layers of filtration is done. So there we have 3 layers of sand and stones. So the first layer or the topmost layer is made of fine sand, which is followed by a middle layer made of coarse sand, and the bottom layer at the lowest part it will be filled with gravel. So when the water is flowed or made to flow through all these 3 levels, even the tiny particles or the small sized impurities present in the water can be removed by doing this 3-layer filtration. Thus, the clean water that is obtained is then pumped into a chlorination tank where a little amount of chlorine gas is added to water. So by doing so, this kills the germs present in it. Thus, after disinfecting the water, it is then pumped to storehouses or storage tanks so that water is supplied to our homes for our needs. So filtration plays a crucial role in our day-to-day life activities. A mixture of suspended particles can be separated from a liquid by using the method of filtration, but it is a time-consuming process. So for that, we can use another method called centrifugation, and if we have to do the method of centrifugation, we must use an apparatus called centrifuge. So in centrifugation, the particles or the mixture is made to rotate at a very high speed in a machine called centrifuge. By doing so, the clear liquid being lighter remains on the top and the suspended particles will get settled down at the bottom. Thus, we can separate a mixture of clay particles from water very rapidly by the method of this centrifugation. In the same way, cream from milk is separated by this method. Also, the blood cells and the plasma together constitute our blood. So, by using the method of centrifugation, we can separate out blood cells and plasma from the blood. Now, we will move on to the third process, and that is evaporation. It is a very common method to all of us. In this method of evaporation, the liquid present in the mixture is made to evaporate, or it is converted into the vapor state, and we will get the solid substance remains at the paper or the glass in which we have taken the mixture. So when we heat the mixture containing a liquid and a solid, the liquid substances turn into vapors and the solid particles are left behind. By using this method, we can separate ink that we use in our pens. So ink is a mixture of water and color dyes. So when we evaporate this ink, the water will evaporate out and we will get dyes separated out of ink. So that's the process of evaporation. Now we will see the fourth method, and the fourth method is called crystallization. Using this method, we will obtain pure solid substances from impure samples. So the process of cooling a hot concentrated solution of a substance to obtain crystals is called crystallization. Impure copper sulfate can be purified by this method. So here, the impure copper sulfate is made to dissolve in water and we will have to filter it so that the insoluble impurities can be filtered out. So the filtered solution of copper sulfate is heated on a water bath. Then we'll have to heat it until the solution becomes saturated. So how do we know the solution is saturated? So we'll have to put or dip a glass rod in this solution time to time. So when the glass rod contains or when a few crystals are attached to this glass rod, we can understand that the solution is saturated. So if it happens, we can stop heating and allow this saturated solution to cool. So while cooling, after some time, we can see pure crystals of copper sulfate coming out of this saturated solution. And the water or the liquid will contain the soluble impurities, and thus we can obtain pure crystals of copper sulfate from impure copper sulfate. So the process we used here is crystallization. Now this crystallization is considered as a better technique than evaporation. This is because of two main reasons. So while doing crystallization, decomposition of solids will not happen. So if you are evaporating and drying the substance, there is a chance of decomposition of solids. This will not happen in crystallization. And the second reason is the soluble impurities will not be removed if we are evaporating the mixture. So if we are crystallizing the mixture, the soluble impurities will also be removed, and finally we will get pure crystals out of the mixture, and that's what we saw in the case of copper sulfate. So that's all about crystallization. Now we will see the fifth technique of separation, which is the chromatography. It is used for separating two or more dissolved solids that are present in a solution based on solubilities. So the different components of a dye or component colors present in ink can be separated by using this method. So here we must take a long strip of filter paper and draw a line about 3 cm from the bottom end. There we'll have to put a drop of ink on the center of this line that we have just drawn. After letting the ink to dry, we must dip this filter paper in a glass jar containing a little amount of water such that the part of the ink or the part containing the ink touches the bottom of the water. But make sure that the level of water remains just below the drop of ink we put on it. Then we will observe the gradual rising of the water level. So as the water rises up, the components of the dye which are more soluble in water will be moving faster, and they will occupy the higher positions on the filter paper, whereas the components of the dyes which are less soluble in water occupies the bottom spaces. Thus, we can separate the components of the ink or components of the dye, and finally we will have 3 or 4 spots in the filter paper. So chromatography is used to separate solutions of colored substances. It is used in forensic departments to detect and identify the amount of substances like poisons in the contents of stomach and bladder. And finally, it is used to separate small amounts of products out of chemical reactions. So in short, chromatography can be used for separating small amounts of dissolved substances. The last method is called distillation. So here I have a mixture of salt and water. So salt is dissolved in water and I want to separate them. So from the methods we have learned that if we do the process of evaporation, we can separate out salt from water. But the water escapes in the form of vapor if we are doing evaporation. What if I want both the salt and water recovered after separating? In such cases, we should go for the process called distillation. So distillation is the process of heating a liquid to form vapor and then cooling the vapor to get back the liquid. So the mixture of salt and water is taken in a distillation flask and is heated. So the water from the solution evaporates and rises up and get into the condenser. As the name says, condenser has a cooling environment and cold water is continuously circulating through the outer tubes in condenser. Thus, the evaporated water, as it reaches the condenser, they condenses or cools and get converted into its liquid form. Thus, all the condensed form of the liquid can be collected in a beaker that is kept outside this distillation flask. So we obtain salt-free or purified water, and the salt that will be remained in the flask. Thus we can separate salt from water and we can recover both the salt and water if we are doing distillation method. So that's all about the 6 process of separation of solids from liquids. Just recall what all are those 6 methods. So the first method was filtration, then we saw centrifugation, then we learned about evaporation, crystallization, chromatography, and finally we learned about distillation. Hope you had a wonderful time together with us. See you in the next session. Thank you.